welcome to Science Access. In today's class, I'm going to take you to part 2 of dimension analysis, and we'll just be taking some questions and answer. I will start with very easy question so that in case you've not watched the part 1, then but I would advise strongly that you should watch the part 1 of this video before watching the part 2. Alright, so just a question and answer. Now, very easy question. What is the dimension of velocity? And velocity formula is actually displacement over time, right? Remember, in dimension, what you are doing is you are representing any formula or equation with the three basic fundamental quantity, L, M, and T. This is length, this is mass, and this is time. So displacement is actually length, right? That's distance. Displacement is distance in a specified direction. So that's length. Any distance is actually length to measure it. All right. So we just have the top is what? L, and time, T. We can represent it as what? L. Remember, this is like 1 all over T, right? So 1 over T is empty as T raised to power what? Negative what? 1. So this is the dimension for what? Velocity. Now we'll go a little bit further to discuss a more challenging question. Then before we now start discussing complex question, let's take the dimension for upthrust. Upthrust. Now the first thing you must know is the formula for that particular thing. All right. So upthrust is actually density times volume times acceleration due to gravity. So upthrust is density times volume times what? Acceleration due to gravity. All right. Now let's rewrite it this way. D times V times G. So we'll now get the dimension for this. Get the dimension for this and get the dimension for this. Remember, density is mass all over volume. So this is M all over V. Volume is length times breadth times height. All right, so L3. So the dimension of density is what? ML what? 3. We'll present this in the appropriate format. All right. Volume again, right? Volume again is length times breadth times what? Height, right? So we now have length is L, breadth is L, height is also L. We now have L raised to power what? 3. Okay. Now this is acceleration due to gravity. Now we can come to this place. Acceleration due to gravity A is equals to what? Velocity all over what? Time. All right. And we know that the dimension for velocity is what? L t negative what? 1 all over another t. Now, if I take this t upward, remember this t here is like 1 all over t again. So if I take it upward, we now have L t raised to power what? Negative 2. So this is the dimension for acceleration what? Due to gravity. Please take note of that. You can watch my part 1 of this video to get clarity, but it's a very simple thing. Acceleration is velocity all over time, and you know velocity is what? Length L, distance, displacement all over what? Time. But because this one is under, I have to take it upward. Following the law of indices, and you have t. This t raised to power negative 1 is empty as 1 all over what? T. And if you use to multiply this, you have this back. Now we now have gravity is V all over what? T. So this is V. Put it here now, all over T. So we now have another 1 all over what? T. So if you take it upward, you now have negative what? 2 as. So here we now have L T raised to the power what? Negative 2. Let's put this way. We can just, this can actually cancel out this, right? So this one can cancel out this. We now have our final answer as M L. This is the L T negative what? 2. This is our final answer for options. Now let's take a more challenging question. At what respective value of x, y, z would the unit of work be dimensionally equivalent to mx, ly, and tz? All right. Now, please take note of this. What you are simply looking for is you look for the dimension of work. Then you now, from there, you can now get the value, respective value of x, y, and z. All right. Now, let's just do it. It's a very simple question, but appear challenging, but very easy. First thing, what is the formula for work? Work is force times distance. All right. Now we can break down force. Work. Now, do you know that force is ma, mass times acceleration? So ma times d. Now, mass in dimensional analysis represents with what? M. Now we can determine the dimension of what? A. Remember, A is actually acceleration, is actually velocity all over time. All right. Why velocity? We know the dimension of velocity is actually L t raised by what? And then so on. Then if we decide to add this, the dimension of acceleration will now be L t raised by negative what? 2. So this is the dimension of acceleration. So times L t raised by negative 2 times. Now, d here is distance. Distance. And distance is length. Take note of that. Distance is actually what? Length, L. So our final answer will now be M. Now, L times A is actually L squared. L squared. T what? Raised by negative 2. Back to our question. What's the value of x? Here, remember that we are specific. M, the first one is M, right? M is actually raised by x. M is raised by 1 here, invisible 1. All right, so we now have x as 1. All right, note that x is equal to 1, y is equal to 2, and z is equal to what? Negative what? 2. So the value respectively is actually 1, 2, and negative what? 2. It's a very simple question. Let's take the last question. Now, the last question we're going to do is simple. Though it may look challenging, but it's a very simple question. Verify the correctness using dimension analysis, this equation of motion. Now, this is a simple equation of motion that you know in your textbook. All right? And you're asked to verify if this equation is correct or not. Please take note. We can make this the subject of formula, put this way, make this the subject of formula. So if you are to verify the correctness, just know that the dimensional analysis of this is supposed to be equal to the dimensional analysis of this, and it's supposed to be equal to the dimensional analysis of what? This. That's just a simple idea behind it. So I'll get the dimension of this. And if it's the same as the dimension of this, and it's also the same as the dimension of this, it is actually correct. For example, you have other equations. You have v equals to what? U plus at. You have others, which is distance. Ut plus what? Half at squared and all that. So if I decide to check the dimension of this, it must be equal to this, and it must also be equal to what? This. So this, we have the same dimension as this. This, we also have the same dimension as this. So just do that. But if it's not the same, what will happen? It says it's not dimensionally what? Correct, using dimensional what? Analysis. It's a very simple thing. So let's just quickly get the dimension of this v squared. Now, so let's continue. The marker was actually giving issues. All right, so v squared is equal to, now, what is the dimension of v? L t raised to power what? Negative 1. So if we decide to square it, what will I get? Now I have S squared t raised to power negative what? 2. So this is dimension. What about this? U square. U is also velocity. This is final, this is initial. Okay, so you have the same answer, negative 1. So if you square it, you have L square T negative what? 2. What about 2AS? Now, 2, for example, does not have dimension. So we are just going to go with AS. Okay. So here, what is the dimension of A? That's the first thing. So dimension of A is actually, remember A is acceleration, right? So and acceleration is what? Velocity all over what? Time. And remember our velocity is what? L t raised by negative what? 1. Okay. So if I decide to put the time back, we now have acceleration will now be, remember, this is actually, this become what? T. And if I take this T upward, it will now become LT negative 2 because this one have, you've taken it to the numerator, all right? It's a very simple indices calculation. So A here will now be LT raised by negative 2. What about S? S is distance, right? Times L. What's our final answer? L times A is what? L square half T what? Negative 2. So we realize that all have the same dimension. So it's actually dimensionally correct. You can take this as assignment. Just do for this same, for this equation of motion. You can do for, let's say, V equals to U plus what? AT. Check if it's actually dimensionally what? Correct. You can also do for S is equals to UT plus what? Half AT square. All right. Let's check if they are dimensionally correct and drop your answer in the comment section. You can send your answer to the Gmail being displayed. But thank you for watching.